A troubling discovery has appeared high on the slopes of Europe's most unpredictable volcano. A newly formed fracture, sharper, deeper, and more precisely cut than anything seen on Mount Etna in years, has torn across the mountainside. And while cracks on volcanoes are not uncommon, this one is different. It sits in a location geologists have watched with growing concern, a place where even a small structural shift could signal a much bigger problem underground. So the question now is unavoidable. Did Etna just reveal the first physical sign of a process scientists have warned about for decades? Today we're examining this developing situation on Mount Etna, the new fracture, what it reveals about the volcano's behavior, and why experts fear Etna's unstable southeastern flank may be entering a more dangerous phase. Because right now, the world's most active stratovolcano isn't just erupting, it's changing shape. A few weeks ago, monitoring teams noticed something unusual on recent satellite scans, a dark line cutting across Etna's upper flank at nearly 10,000 feet. When investigators reached the site, they found a fresh crack that looked almost artificially carved into the mountainside. The rock faces were clean, the edges sharp, and the depth significant. Clear evidence that it wasn't caused by erosion or surface weathering. Something inside the volcano had forced the rock apart with considerable strength. What made the discovery even more unsettling was its position, directly above the zone where Etna is already sliding toward the sea. Etna's southeastern flank is not anchored the way most volcanic cones are. This entire section rests on layers of fractured bedrock and sediment that naturally drift downslope over time. Scientists have tracked this movement for years using GPS receivers, radar imagery, and interferometric satellites. Their measurements show slow but steady migration, creeping motion measured in millimeters per year. But the sudden appearance of a deep, fresh fracture suggests something has changed. The slow slide may be picking up speed, and if the motion is accelerating, the volcano could be approaching the critical threshold predicted by collapse models. The moment when gravitational pull, internal pressure, and structural weakness begin acting together instead of against each other. That tipping point is what volcanologists fear most. So what exactly opened this fracture? The answer isn't clear yet, but two possibilities dominate the discussion, both serious. 1. Rising magma inside the volcano is building outward pressure, straining the volcanic shell. 2. The flank itself is slipping more rapidly toward the Ionian Sea, and if both are happening at the same time, the risk escalates dramatically. History shows that the combination of internal inflation and downslope sliding is the classic signature of a volcano preparing for structural failure. Volcanoes deform the same way pressurized containers do. When magma rises quickly, it forces the entire cone outward. Rock doesn't stretch, it fractures, shifts, separates. And if the outer flank is already unstable, gravity helps tear it away from the main structure. This exact sequence has been documented in multiple volcanoes that experience catastrophic flank collapses. Those events were sudden, massive, and preceded by warning signs nearly identical to what has now appeared on Etna. A volcano does not crumble slowly. When its flank loses integrity, the collapse happens fast, sometimes in seconds. If Etna's southeastern flank were to detach, an enormous block of volcanic rock, several kilometers wide, would crash downslope into the Ionian Sea. Geological studies show that Etna is effectively resting on a tilted platform that is slowly giving way. A collapse of this magnitude would displace huge volumes of water and produce a tsunami capable of striking Sicily's coast within minutes. Catania, home to more than 300,000 people, lies directly in the path of such a wave. Smaller towns would have even less time to react. Depending on the scale, the effects could spread far beyond Italy, with wave energy reaching Malta, Greece, and North Africa. At the same time, the sudden removal of mass could destabilize Etna's magma chamber, triggering explosive activity, towering ash plumes, and destructive pyroclastic surges. This is why volcanologists reacted immediately when the new fracture appeared. This is the scenario they're evaluating now. Why would Etna show signs of structural weakness now? To answer that, scientists are looking at the volcano's recent behavior. In the past few years, Etna has undergone multiple periods of rapid inflation, times when magma rose quickly and pushed the cone outward. During each cycle, the unstable flank stretched a bit more, inching toward the sea. Those cumulative movements may now be reaching a breaking point. The new fracture might be the first visible sign that the pressure inside the volcano is no longer just lifting the summit, it may be pulling the mountain apart. In 2018, a major marine geophysics study revealed that Etna's submerged flank was sliding in one coherent block along deep underwater faults. This showed that the instability extends from the summit all the way to the ocean floor. Now, with a major fracture at high elevation, scientists fear that the entire flank, from the top of Etna to its underwater,